500 million miles from the Sun. The boss of the planets, Jupiter. Of all the planets in the solar system, Jupiter's immense size gives it an incredible influence. And while Jupiter is at a safe distance from Earth today, in the past, it drew much closer. 4.5 billion years ago, it embarked on a rampage across the solar system, leaving a trail of destruction in its wake. Jupiter transformed the destiny of the planets, and could even have changed the course of life on Earth. Beyond the edge of the inner solar system and the desolate wasteland of the asteroid belt is the gas giant, Jupiter. Its serene marbled appearance disguises a planet in turmoil, where violent storms rage through clouds more than 1,000 miles deep. It's intensely beautiful and very mysterious. The clouds hide whatever's beneath. But Jupiter is a planet that's as influential as it is beautiful. It's the most powerful gravitational object in our solar system, second only to the Sun. 4.5 billion years ago, Jupiter's gravity had devastating consequences for the worlds around it. Jupiter had an incredible effect that helped shape the solar system as a whole. Clearing material from the inner solar system, it transformed the destiny of the planets, including our own. Jupiter is a world with a dark past. And you don't have to look far to see the evidence. In the northern Arizona desert, this is Barringer Crater. It was formed 50,000 years ago when an iron-nickel asteroid 150 feet across hit the Earth at 27,000 miles per hour. An asteroid that was likely thrown in our direction by Jupiter. So what is it that enables it to influence Earth from so far away? And how did it grow to such dominance? Only by seeing Jupiter up close could we begin to answer those questions. In 1972, Pioneer 10 became the first spacecraft to cross the asteroid belt. Before then, we really didn't know whether or not it would even be possible for a spacecraft to survive the trip. The images sent back by Pioneer 10 amazed and excited scientists. It showed for the first time Jupiter's dynamic and violent atmosphere. During its brief flyby, Pioneer observes Jupiter for 4 days, proving that missions to the outer solar system are possible. The Voyager spacecraft see Jupiter's Earth-sized red spot in unprecedented detail, discover the planet's rings, and capture the first detailed images of Jupiter's moons. It wasn't really until Voyager's pictures that we really understood how incredibly rich and complex the Jupiter system truly is. The icy surface of Europa, the volcanoes of Io, Ganymede with its broken appearance, Callisto absolutely covered with impact craters. We now know the giant has more than 79 moons. Jupiter is a world so large, its immense gravity has assembled a solar system in miniature. So how did it grow to such an incredible size? In 2011, the Juno spacecraft launches from Cape Canaveral. Its mission: to uncover the secrets of Jupiter's formation. After traveling for 5 years, on July 4th, 2016, the spacecraft finally arrives. It's an incredible moment for the science team. The images they receive are mind-blowingly beautiful, full of vivid colors and intricate details. One of the most stunning discoveries made by Juno is that the poles are actually blue. But Juno does more than take pretty pictures. It peers deep into Jupiter, probing the structure of the planet. Because knowing more about it helps us tell where and how Jupiter was formed. By analyzing the planet's magnetic and gravitational field, Juno is able to look deep into Jupiter's interior. By discovering that core, it helps us reconstruct Jupiter's first moments. A story that begins very early in the solar system's history. Nearly 5 billion years ago, a distant exploding star sends a shockwave across the galaxy. causing the cloud and dust that would become our solar system to collapse, forming the Sun. Farther out, Jupiter's core is already beginning to grow, gathering in vast clouds of gas. After 50 million years, the Sun's nuclear furnace ignites. The light of its first dawn, revealing Jupiter. While the terrestrial worlds are little more than rubble, Jupiter is fully formed, allowing it to shape everything that follows. It is the most influential and powerful planet in our solar system by far. Over the next 100 million years, the 4 rocky planets of the inner solar system form in their familiar positions. Mercury, Venus, Earth, then Mars. And while this layout is familiar to us, it might be extremely rare. The more we find out about our galaxy, the more likely it seems that our solar system is atypical. Our Sun is just one of around 300 billion stars in our galaxy. And almost every one of those stars is likely home to its own system of planets. We call them exoplanets. And interestingly, it's not Earth-like or Jupiter-like exoplanets that are the most common. The vast majority of exoplanets that we find have sizes and masses that are similar to Uranus or Neptune. In most other systems, the region of space where our planet orbits is empty. Instead, close to the star, we see super-Earths. Vast rocky planets between 2 and 10 times the mass of Earth. But these planets are thought to have thick, suffocating atmospheres that render them inhospitable to life as we know it. So what is it that makes our system so different? As we've explored the planets, we've discovered strange anomalies that hint at a catastrophic upheaval that shaped our solar system. Our mission to Venus found that it once had far more water than you'd expect for a planet so close to the Sun, just as Earth has today. The spacecraft we've sent to Mars touched down on a world that is curiously just half the size of our sister planets, Earth and Venus. But it was in the region of space closest to Jupiter that our probes discovered the most astonishing evidence. The asteroid belt is located between Mars and Jupiter, and it separates the inner from the outer solar system. People think that the asteroid belt is densely packed, but the asteroids are actually widely separated. They're spread over a huge volume, so huge, in fact, that if you stood on one of those asteroids, you wouldn't be able to see another one. The asteroid belt is nothing like the ones you see in Star Wars. It's mostly empty space. But it hasn't always been like this. It's thought that the asteroid belt once contained enough material to build a planet the size of Mars. So why is it so empty today?
5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Dawn's mission is to investigate the two largest asteroids in the asteroid belt, Vesta and Ceres. After a year in orbit around Vesta, in March 2015, Dawn makes its final approach on Ceres, a body that makes up over a third of the entire belt. An object that had been grainy and mysterious was suddenly revealed to us, ready for exploration. On approach, the first images Dawn sends back to Earth reveals something unexpected. As Ceres comes into view, numerous bright spots, like pockmarks, are observed. Nothing like anything else observed on Ceres. The outstanding ones are found in Ocketer Crater. Ocketer Crater is one of the larger and younger craters on Ceres. The most intriguing thing, though, is what we see in the center, a dome, made out of super bright material. Now the mission team's challenge is to identify what that mysterious substance really is. With the instruments of the Dawn mission, we're finding out that the chemical fingerprints of the bright material are salts. All of this points to the fact that there were once brines, salty waters, close to the surface of Ceres, creating these deposits. Dawn goes on to discover over 300 bright spots, clues to Ceres' former life. If we were to peel away the dark surface of Ceres, what we would find underneath is a mixture of rock and ice. Ceres is not just the largest asteroid, it's a dwarf planet in its own right. It's spherical and has differentiated into layers, with its outer layer comprising of a 10-kilometer thick layer of ice. But it hasn't always been this way. Ceres is frozen today, but early in its history, radioactive elements in its interior would have provided heat that melted the water ice. So Ceres would have had a global ocean. In infancy, Ceres was well on its way to becoming a fully fledged world. The water that now lies frozen within its interior was once liquid. Protected beneath a thin layer of ice, ancient Ceres is covered by a deep saltwater ocean. But then, something happens to cut its development short. the young Jupiter circles the Sun, it clears a path through the gas clouds that envelop the early solar system. But the process causes it to do something alarming. Jupiter begins to spiral inwards, plowing straight through the region of space that would become the asteroid belt. When the young Jupiter moves through the primordial asteroid belt, objects get gravitationally deflected and thrown around. In fact, more than 99% of all the mass that was once there is now gone. These protoplanetary cores, like Ceres, were never able to graduate to fully fledged planets because there was just not enough material in the orbital neighborhood. When Jupiter passed through the primordial asteroid belt, it starved Ceres of material, halting its growth. And the dwarf planet was condemned to spend eternity as a cold, barren rock. But Ceres isn't the only world in our solar system whose development was cut short. Mars would share a similar fate. After marauding through what would become the asteroid belt, Jupiter enters the region of space where Mars is forming. Continuing its journey, spiraling towards the Sun. As Jupiter bulldozes inwards, its immense gravity scatters material in all directions. Some are sent careening into the Sun, and some are thrown into interstellar space. It's because of the gravitational clearing of this neighborhood by Jupiter that Mars was unable to grow to more than 10% of that of the Earth. This is why Mars is small. And by clearing material out of the inner solar system, the giant may also have prevented the formation of the super-Earths we see in other systems. And if it had continued moving inward, our planet too might have never been formed. But then, just as it looks like Jupiter will sweep everything away, the giant planet stops in its tracks. Because in the far reaches of the outer solar system, another planet is forming. The solar system's second giant, Saturn. And its arrival changes everything. As Jupiter moved inward, Saturn also moved inward and caught up with Jupiter's orbit. When this happened, they locked into a special configuration known as mean motion resonance, and in this configuration, the two giants reversed their migration course and moved back out. Saturn caused Jupiter to retreat. Leaving behind just enough material from which the inner planets could form. Mercury, Venus, and our home, Earth. Earth is exactly in the right location to provide the environment for life to develop. So perhaps, if Jupiter's orbit hadn't been corrected, life would have never formed. So as its voyage across the solar system draws to a close, Jupiter helps provide our living world with its most precious ingredient. Today, 2/3 of our planet's surface is covered by oceans. More than 320 million cubic miles of water. Each drop teeming with life. One of the big questions about the evolution of our solar system is how did we get water here on this planet? We suspect that the inner planets didn't form with a lot of water. Water is primarily in the outer solar system. However, Jupiter and Saturn's orbital movements may have sent water towards the inner planets. Locked in a gravitational dance with Saturn, Jupiter moves back through the asteroid belt. And as it does so, water-rich material is flung inward, where it is incorporated into the growing terrestrial worlds. The movement of the giant planets have played an important role in delivering water to the inner planets. And it may be that we have Jupiter's outward dance to thank for our water. Earth would be quite different if not for Jupiter. Today, Jupiter has settled into a regular orbit, back beyond the far edge of the asteroid belt. Its days of marauding through the solar system at an end. But its gravity remains a constant threat. And nowhere is that more apparent than on the closest of Jupiter's large moons, Io. Io is the most volcanic world in the solar system. If you were to take a picture of Io, it would show hundreds of volcanoes erupting simultaneously. The biggest lava flow on Io is Loki-Patera. At more than 120 miles in diameter, it's 1,000,000 times the area of any lava lake on Earth. Its surface constantly churned by waves of molten rock. But Io is the same size as our moon. So why isn't it just as cold and dead? Jupiter is a massive planet. It's 318 times the mass of Earth. Io orbits this giant while at the same time it has to contend with Jupiter's other moons constantly pulling it out of a circular orbit because of their orbital resonance, which means that the moons keep meeting up at the same point in space constantly. That in turn means that there is a recurring tug on Io. That tugging becomes friction, and friction becomes heat, just as surely as rubbing your hands together on a cold day. Scientists call this tidal heating. By repeatedly being stretched, Io builds enough heat to melt rock. The process raises the temperature of Io's interior to more than 2,000 degrees Fahrenheit, creating its lava lakes and powering immense volcanic plumes that rise 200 miles from the moon's surface and out into space. Because of Jupiter's size, the gravitational field that drives Io's volcanism extends far beyond its moons, even as far as Earth, where there's evidence it's done far more than create the occasional crater. Jupiter has been implicated in periodic extinctions of life on Earth. It's quite likely that the asteroid that wiped out the dinosaurs almost 70 million years ago was launched from the asteroid belt by Jupiter's gravitational influence. People often think of the asteroid belt as this unstructured, unchanging population of debris. But the asteroid belt as a whole dances to Jupiter's tune. But it's a delicate balance that can change at any time. Because Jupiter exerts such tight control over the long-term changes of asteroid orbits, if an asteroid is not in the place it needs to be, chances are Jupiter will fling it out of the belt at tremendous speed and potentially even send it towards Earth. Dislodged from its orbit by Jupiter's gravity, an asteroid 6 miles across tumbles out of the asteroid belt. It is now on a collision course with Earth. When it strikes, the impact generates a fireball so hot anything within a 600-mile radius dies instantly. The impact throws some 300 billion tons of sulfur up into the atmosphere. And during the nuclear winter that follows, 75% of species, plant and animal, are wiped from the face of the Earth, including the largest creatures to ever walk on its surface. By driving the dinosaurs to extinction, Jupiter clears a way for us to inherit the planet. And although it still occasionally flings asteroids our way, Jupiter also protects us. For objects heading towards Earth from the farthest reaches of the solar system, the giant planet's immense gravity acts as a shield. Around 100 years ago, a lump of rock and ice 2.5 miles across is hurtling towards the inner solar system. But Jupiter stands in its way. 70 years later, a mission launches that will witness just how effective a shield Jupiter can be. On board the Space Shuttle Atlantis, the Galileo Orbiter. Three years after Galileo launches, comet Shoemaker-Levy 9 has been captured by Jupiter's gravity. And now, locked in the giant planet's deadly embrace, tidal forces begin to tear the comet apart. Its journey into the inner solar system cut short. What happens next presents Galileo scientists with a unique opportunity. They realize that the comet fragments will crash into Jupiter 2 years later. After crossing the inner solar system, Galileo is approaching the spot where it will witness the comet's final moments. The images of it recorded and sent back to Earth. On July 16th, Galileo sees the first fragment of the comet enter Jupiter's southern hemisphere. Hitting at 60 kilometers per second, the fragments heat up the area of impact to almost the temperature of the Sun. Pieces of comet Shoemaker-Levy 9 strike Jupiter's over the course of 6 days. These powerful pulses of light, captured from 150 million miles away, are the only times we've witnessed a comet strike. The most destructive of these impacts releases more energy than 6 million megatons of TNT, equivalent to about 400 million Hiroshima bombs, leaving behind a dark cloud 7,500 miles across. By capturing objects and incinerating them on impact, Jupiter protects us from bodies that might otherwise threaten Earth. Galileo would go on to study Jupiter for another 8 years. Galileo records 400 miles an hour winds in Jupiter's clouds and measure lightning strikes many times more powerful than those on Earth. It also gives us our first detailed look at Jupiter's moon Europa. Galileo's pictures confirm Europa is an ice moon. Analysis of its magnetic field reveals Europa's cracked surface floats above an ocean 60 miles deep, which contains more water than all the oceans of planet Earth. Then, on September 21st, 2003, Galileo meets the same fate as the comet that had greeted its arrival. NASA won't risk the spacecraft accidentally hitting a moon that might harbor life. So before all the fuel is gone, Galileo is set into a collision course with Jupiter. Jupiter. The oldest and largest of the planets is the boss of our solar system. In youth, it went on a rampage. For some young planets, that spelled disaster. But for others, like our own world, it cleared the way for their formation. And so Earth and all of humanity owe Jupiter a great debt. But the fate of the dinosaurs is a reminder that it's a debt that could be recalled at any time. The evolution of the solar system is never really done. Scientists can only predict so many millions of years into the future before the models become chaotic and unreliable. So the story of Jupiter has one final twist. Long-term calculations predict that there is a very slight chance that Mercury's orbit can become exceedingly elliptical as a result of gravitational interactions with Jupiter. This would have dire consequences for the inner solar system. Mercury could be thrown into the Sun, flung into interstellar space, or even set on a collision course with Earth. In every one of those scenarios, the gravitational effects will destroy life on Earth, even if it doesn't hit us. And so, Jupiter, the giant that shaped the birth of our world, might one day bring about its destruction.